We'll look at the bilging problem here, where we have a box-shaped vessel. We're given our kg, length and breadth and draft, with a deep tank midships, 15 metres long by 4.36 deep, extends over the full breadth of course, and it's tightly stowed, cargo density given and the stowage factor given. Calculate the new draft and GM. So always important to do a sketch, and when you do the sketch you can see straight away that our water plane area is intact. Okay, so that's the first thing. So let's have a look at calculating the new draft first. So conveniently on your formula sheet in your data booklet, these formulas are actually in sequence. So solid factor 1 over RD 0.96, permeability solid factor, stowage factor minus solid factor over stowage factor 0.314, effective length of the compartment 4.71. Now I would suggest at this point, if you were doing this problem, once you've got that new length of 4.71, cross the 15 out and put 4.71 there, because you're not going to use the 15 meters at all for the rest of the problem. This is the only time you use that 15 meters. So sinkage 4.71, breadth, draft 4.36, not draft, depth of the watertight compartment. Just to reiterate there, the draft is 6.2, but when we're working out the volume lost, it's 4.36 obviously, because it only goes up to that height. The intact water plane is the full length and breadth, so our sinkage is 0.25, final draft is 6.45. Then it asks to calculate the GM. So to get the GM we need the KM, we've got the KG, and to get the KM we need the KB and the BM. So when we look at this here, to get our KB we must do the volume table, because we've lost this portion, so the resultant underwater volume left is even on each side of it, but then we've got this section here that we have to take into account. So the final KB 6.45 times 14, so length, breadth, new draft 6.45, 6.45 over 2, and then we simply take off our compartment. So it's 4.36 deep, it's just mentioned here 4.36, so that's the depth, breadth and the height there. So 4.71 is the length, the breadth, and then that's the 4.36 at the top. That gives us our volume. Divide the 4.36 by 2, that gives us the moments. Subtract one from the other, KB 3.267. BM, our water plane area is intact, so we could have just written this as B squared over 12D, and we get 2.634. Add the KB and the BM, 5.901. Subtract it from the KG, and you get a GM of 0.101. Could have written 0.10 there really, and I guess I should have done, because you can't be more accurate than the tables, and the tables would only give KM and values, kgs, two decimal places. So straightforward that one, but always think that you should do a sketch. Definitely do a sketch to help you solve the problem.